Day 2 of multiplying and dividing rational expressions. Today we're actually getting to the multiplication and division though. I mentioned yesterday that you have all of the necessary skills to do this. Because when it comes to multiplying and dividing our rational expressions, it comes down to the exact same rules that you learned about with fractions once upon a time. How do we multiply fractions? It's not cross multiplication. That's when it's a proportion. That's a fraction equal to a fraction.
Multiply across.
You multiply straight across. 10 times 6. Why am I writing a 7? 60. 3 times 25. 75. And then we simplify our fraction. 60 and 75, biggest thing that divides out of both of them. Bigger. 15. And you get 4 over 5. That is one way to do it. There's another option. One thing that can help make life a little bit easier when multiplying is you can simplify as you go. If you know the 10 and the 6 are going to end up in the numerator together, multiplied together, and so are the 3 and the 25 in the denominator, though, you can simplify things on top with things on bottom. For example, I notice a 10 on top and a 25 on bottom. What do they both divide by? 5. Leaves me with a 2, leaves me with a 5. And I notice a 3 on bottom and a 6 on top. What do they both divide by? 3. Leaves me with a 1, leaves me with a 2, and then I multiply straight across. 2 times 2 on top, 1 times 5 on bottom. 4/5. It can save you some of the simplifying doing it that way. You don't have to do it that way. There's nothing going to be any great advantage of doing it that way when it comes to what we do today, but it is something that saves a little bit of writing sometimes. Now that's multiplying. Today we're also going to be dividing. Here's the thing, you also, in theory, have the skills to divide fractions too, or at least you should. How do we divide fractions? Multiply by the reciprocal. Keep, change, flip. Sound familiar? Flip the second guy and multiply. Depending on who you had as a math teacher, technically it's multiply by the reciprocal. So what you do is you keep the first fraction what it was, change it from divide to multiply, and flip around the second fraction. Now it's multiply. And to multiply fractions, you can multiply straight across. 4 times 7 is 28. 3 times 2 is 6. They both divide by 2, giving me 14 over 3. Now, if you wanted to divide where you were simplifying before actually doing the multiplication, you cannot do that until you get to the multiply step. In this multiply step, could I have simplified these fractions before multiplying them? Yeah, 4 and 2 both divide by the 2. I would have ended up with 14/3. But you gotta wait till that multiply step to do that. Rational expressions follow the exact same properties. Because rational expressions are just a more complicated looking fraction. The only thing that's truly different with them is excluded values. When it comes to multiplying rational expressions, most of the time I don't simplify beforehand when it's monomials like this. I just straight up do the multiplication, and then I'll teach you a little hint to figure out how to simplify down if you're struggling with that. 4x squared y getting multiplied by 3x. Are you allowed to multiply non-like terms? Yes. It's one of the common things I get people stuck on every time. They say, like, well, how do I multiply these? They're not like terms. And the answer is you multiply just the parts that actually can combine, like the numbers and the x's and then the y's. 4 times 3. 12. I got an x squared and an x. X to the third power, because when you're multiplying variables, you add their exponents. The invisible exponent there is 1. And then I got a y. That's not multiplying by any other y's, so it's just y. Do the same thing in the denominator. 12 and 8. 96. I got an x. I got a y cubed and a y. Y to the fourth. And then I simplify. Look for the biggest thing that divides out of both 12 and 96. It is 12. If it's not obvious what divides out of it, go back to the smaller numbers and look at the numbers on top and bottom. I see 4 and 8. What do they both divide by? 4. I see 3 and 12. What do they both divide by? What's 4 times 3? Hence, they both divide by 12. Okay, divide them both by 12. On top, I'm left with 1. On bottom, I'm left with what? 8. So I get 1 on top, 8 on bottom. X cubed over x. I can pull an x off of both of them. That one disappears. This one becomes x to the power of 2. So there's an x to the power of 2 on top. Y on top, y to the fourth on bottom. Can divide them both by y. These y to the third on bottom. That's our simplified form. Wait a second. Hold up a minute. Did I not say that you had to factor things to simplify? Like, I feel like I said that earlier today already. Why didn't I factor first? There's no adding or subtracting, so it cannot factor. It's just multiplication going on within each fraction. If there was a plus or a minus sign, then I'd be looking at factoring. Now, my instructions don't say find the excluded values. Technically, neither did your homework yesterday, because it's technically considered a part of simplifying. To find excluded values, you set denominators equal to 0. You set anything that ever ends up in the denominator equal to 0. The things that ended up in the denominator here, 12xy cubed and 8y, resulting in 96x y to the fourth. That, technically you can set equal to 0, but if you set these two equal to 0, you're going to get all of your excluded values. When there's no addition or subtraction, this is easier to see. How do I solve that? It's just a bunch of stuff getting multiplied together. What's the only way you get a bunch of stuff multiplied together give you 0? You better have multiplied by 0. Some of this better be a 0. Can the 12 be the 0? Can the x be the 0? Can x be 0? X equals 0 is one of our excluded values, but I don't leave it as an equal, I change it to a not equal. Can y cubed be 0? Yes, but you probably have noticed by now, if I get a variable to a power equal to 0, but nothing else going on, doesn't that just mean the variable is 0? So y equals 0, but it's not allowed to be equal to it. Am I going to get anything new by setting 8y equal to 0? No. Do I technically need to do it? If it gives me a different one, but I would set this equal to 0 if it gave me a new excluded value. It doesn't, so I move on. X over 8y squared divided by 4x over 6y. How do you divide fractions? Flip, which one? Second one. Keep, change, flip. Keep this fraction the same. Change the divide to a multiply. Flip that fraction. Once it's multiplied, to multiply fractions, you multiply straight across. Could I have factored any of this? No. No pluses or minuses again. 30xy over 32xy squared. 30 and 32, biggest thing they both divide by. 2. That becomes 15, that becomes 16. X on top, x on bottom. Cancels out completely. Y on top, y squared on bottom. Take one y off of both, it leaves a y on the bottom. 15 on top, 16, and y on bottom. Excluded values. I set what's in the denominator equal to 0, and you could do it. You should do it with anything that ends up in the denominator. Technically, if you recognize that you've already got it, you don't need to do it. 8y squared was equal to 0. Divide by 8. Get rid of the squared. Y is going to be 0. Except not equal. 6y equal to 0. Guess what? Y is still not equal to 0. Did I have to do this one if I already knew this? No. But are those the only two things that end up in the denominator? No. Those are the original denominators. but 4x also ended up in the denominator. So I also have to recognize that that is not allowed. So be careful with those divide ones. Now, it should not be shocking that they're not all going to be monomials, though. And in my experience, because I've been teaching this for a very long time, because we do a unit on this in FST as well, people actually prefer the ones that have the polynomials. Even though they look scarier. So, 2x plus 10 over x squared minus 9 times x squared plus 3x minus 18 over x squared minus 25. Do you notice there's an x squared at the start of both of these fractions, or both of these terms in the fraction, numerator and denominator? Can I cross it off? No. People do it all the time. They try to cross that off. You cannot cross that off because these fractions have addition and subtraction. Which means the only way you're crossing anything off is if it is factored. Pluses and minuses all need to be in parentheses before you can cross anything off of them. So I'm going to be factoring some things. I tend to factor off to the side. Unless I notice it's a simple factor, then I don't necessarily have to. 2x plus 10. Can I factor it? Remember, always check GCF. Biggest thing divides out of both. 2. So can it factor? Yes. Leaves me with x plus 5. Can I factor it further? No, it doesn't have an exponent. GCF's all you got. Okay, I've also got an x squared minus a 9. Can I factor that? What kind of factoring? What's the shortest way, the quickest way to factor that? The difference of squares. If you prefer the shortcut method for this one, it would work out just as well. Two things that multiply to negative 9 but add to 0. 3 and negative 3. But it is a difference of squares. The first thing that got squared, x starts in both. The second thing that got squared, 3. Has to be a difference. If it's not minus, it doesn't factor. If it's a plus sign, it does now factor, even if it was x squared plus 9. One's a plus, one's a minus. Okay, so that's my first fraction. 2 into x plus 5 over x plus 3 and x minus 3. Okay, now I take the second fraction. X squared plus 3x minus 18. Then I factor it. Greatest common factor is 1. So I move on. It's quadratic, which means AC method, or it's shortcut, or might be it's a difference of squares. Shortcut's the fastest way on this one. Two things that multiply to negative 18 but add to 3. I heard 3 and 6, but which one has to be negative to make this work? The 3, because I want it to add to a positive 3 and multiply to a negative 18. X plus 6, x minus 3. X squared minus 25. also a difference of squares. First thing that got squared here was an x. The second thing that got squared to get the 25 was 5. One's a plus, one's a minus. So my second fraction, x plus 6, x minus 3 on top, x plus 5, x minus 5 on bottom. Notice I factored before I multiplied. I factored before I multiplied because far too often what people try to do is they take these polynomials, and to multiply them you would have to distribute them out. A binomial times a trinomial. You would end up with something that's to the power of 3. And you'd have to be factoring it, which would cause you to factor by grouping. And then after you factored by grouping, if you could factor by grouping, that is, you'd have to do more factoring. You're giving yourself more work, or you're giving yourself a situation where there's something that you actually have never learned how to factor. So factor first. Is it multiply or divide? It's multiply. How do you multiply fractions? Straight across. You want to know the lazy way to multiply? When they're fully factored like this? Ta-da. They are now one fraction. Because when you multiply them together, all you're going to do is write them all by side. It's all side by side. You're going to write a 2 and a parentheses x plus 5 and a parentheses x plus 6 and a parentheses x minus 3. And an x plus 3 and an x minus 3 and an x plus 5 and an x minus 5 in the denominator. Lazy multiplication. Just make them one fraction. Ta-da. It only works on ones that are factorable in binomials. What can I cancel? What's it got on both top and bottom? It's got an x plus 5 on top and bottom. What else does it have on top and bottom? It's also got an x minus 3 on top and bottom. Two is left on top, x plus 6 is left on top. X plus 3 is left on bottom, x minus 5 is left on bottom. Could we distribute it out? Yes. Do we need to? No, I'm fine if you leave it like this. What do we still need to find, though? Excluded values. Anything that was in the denominator gets set equal to 0. You can go with the factored forms. This was this and this. X plus 3 equals 0, x minus 3 equals 0. X is not allowed to be equal to negative 3, x is not allowed to be equal to positive 3. That was the first fraction. X plus 5 and x minus 5 are in the denominator of the second fraction. X is not allowed to be equal to 5, x is not allowed to be equal to negative 5. Was there anything else that at one point or another ended up in the denominator? No. It's not a divide problem. On a divide problem, you'll end up with more things in the denominators. I've got 2 more total examples for y'all. Gesundheit. 4x minus 16. Oh, 2x squared minus 9x minus 5. Divided by 3x plus 12 over 12x plus 6. Andy, what do you think I should do first in this problem? We can flip first. First one does not flip, ever. Leave it alone. Second one flips. That isn't our only possible starting point. There's something else we could have done first. It's what we would do now that we have flipped it. Jacob, what would you tell me to do next? GCF. Start factoring. And GCF is how we start factoring. I see pluses and minuses. The only time I'm not factoring is when there's not an addition or subtraction. So I'm taking this 4x minus 16 off to the side. Now Jacob said to do GCF on that, probably. Mateo, what's the biggest thing that divides out of both of those? Yup. Leaves me with x minus 4. Okay, I also need to factor 2x squared minus 9x minus 5. Grace, how am I factoring that one? Full AC method. There's no way around that because GCF's 1 and there's a coefficient that's not 1. So off to the side, 2 times negative 5 is negative 10. I need two things that when I multiply them together, I get negative 10, but when I add them, I get 1. Sorry, I get negative 9. What am I looking at? Burton? Thoughts on things that multiply to negative 10 but add to negative 9? Negative 10, positive 1. Can I go to parentheses now? No. I cannot go to the parentheses at this point. Emma, if I can't go to the parentheses, what do I write? Exactly. And I do the GCF of each half. Owen, what's the biggest thing that divides out of 2x squared minus 10x? 2x. Leaves me with x minus 5. Preston, what's the biggest thing that divides out of 1x minus 5? 1. Stay put, please. Brandon, what's the fully factored form then?
Parentheses 2x plus 1 and parentheses x minus 5.
You got it. Okay, so far I have 4 and x minus 4 over 2x plus 1 and x minus 5. This is why I do the factoring off to the side. Particularly AC method's a long one. That and factoring by grouping. Okay, next one. 12x plus 6. Caden, how can I factor that one? What is the GCF? Leaves me with 2x plus 1. Can I factor it further? No. X plus 12. Jace, how can I factor that? GCF, what is it? You got it. Leaves me with x plus 4. Isaac, how do I multiply fractions again? Straight across. Can I make lazy multiply? Kind of ish. There's one problem with lazy multiply here. I got multiple monomials. The 4, the 6, the 3. Monomials should go on front and should multiply together. Adam, what can I simplify? Beautiful. Elsie, can I simplify anything else? Parentheses don't match, but 24 and 3 both divide by 3. The monomials will simplify with the monomials, the binomials with the binomials. 8 and x minus 4 left on top, x minus 5 and x plus 4 left on bottom. For excluded values, you got to remember everything that ended up in a denominator. We've got the originals, these ones, which factored to this and this. So 2x plus 1 equals 0, x minus 5 equals 0. Technically, that 12x plus 6 factored into a 6 and a 2x plus 1. The 6 is never going to be 0. 2x plus 1, I already have an equal to 0 option. But also remember you flipped this. So the 3x plus 12 that was originally on top is now something that's in the bottom. So I also need to do an x plus 4. X is not allowed to be equal to. That's going to give you negative 1/2. That's going to give you a positive 5. That's going to give you a negative 4. So there's a little bit more work to multiplying and dividing as compared to yesterday. But most of the stuff is the same. I do have one more quick example, and it is a quick one, partially because of how I'm going to go through it, and I want to do it though still because of the fact that it's got some tripping points that catch people. Not all fractions are pure monomial or pure polynomial. Some of them have monomials and polynomials, like these ones. If it doesn't have a plus or a minus, you cannot factor that piece. So that x squared is going to just stay x squared. I should probably flip these, shouldn't I? Some of y'all will flip and factor at the same time. I'm okay with that. Just make sure you're putting things on the right side of the fraction. But the x squared is going to stay the x squared. Can I factor x plus 3? Some binomials will not factor. If it does not factor, put it in parentheses. Because it is its factor. And that's going to help you with the binomials and the binomials. X squared plus 3x, I can factor out an x. It'll leave me with x plus 3. X to the fourth doesn't have a plus or minus. It will not factor. Lazy multiplication doesn't work very well here because of those monomials again. Monomials do multiply. For some reason, that trips people up more than what I can see, and people leave it as x squared times x. Simplify. What is x squared times x? X to the third power on top. Got an x plus 3 on top as well. Monomials go in the front, so the x plus 4 moves to the front. And I still have the x plus 3 on the bottom as well. Far too often I see people do this and leave the answer as x cubed over x to the fourth. Simplify those as well. What can you divide off of both x cubed and x to the fourth? X to the third power, x cubed. That one will disappear. What's left on bottom? Just a regular x, or an x to the first if you prefer. The other thing I see people do is they now tell me that the answer is x. Where is that x left? The bottom of the fraction. If nothing is left on the top, what's in the top? 1. So be careful of those little tripping points. Problems like this have a lot of tripping points. The excluded values on this one are just going to be x is not allowed to be equal to 0 and x is not allowed to be equal to negative 3. Okay, I spoke far long enough. So we're on page 374 again, 9 through 18, 23 through 30. What's happening on Monday? Quiz. There are no notes on Monday. You're going to get a chunk of work time before your quiz on Monday. The only thing happening on Monday is the quiz. And no, it's not a long quiz. It's same as usual, mini quiz. One side of a sheet of paper. But you're going to get a little bit of time on Monday to work on things before going into your quiz.